Hi, I'm Daz, and what I have here today is 3 Fieldfare Fergusons. None of them are in particularly good state, and I'm just hoping that I can make something good out of one good one out of the lot of them. In this case, this one has got a good panel here. This one, it's completely blank and it looks like it's very corroded inside. So I don't think there's much hope for that one. And this one, it's again, the writing's gone a bit. So I think I just need to choose which colour one I would like and just see if we can make something good out of one of these 3 radios. I didn't pay much money for them. I've been looking for ages. I don't often see them, but what I do like is these 2 dials here. This is what I definitely do like about these. Well, I've taken the red one apart. You can see we've got a separate amplifier board, an RF board. And of course, it's full of those annoying 4-pin whisker collecting devices. The volume control and wave change are a single control, so they're sort of one's mounted behind the other here. It's a reasonably thick ferrite rod, it isn't terribly long. There's the transformer on the speaker, but from what I've fathomed out, yes, it's only got 3 wires. This is an auto transformer, so it's only got one winding. So we've got the usual Plesley capacitors. Not sure if it's worth bothering restuffing them with a radio like this because you don't look inside. Not with the battery compartment located here. It's a PP1. 2 ganged capacitor, and one set of vanes is smaller than the other, so that's sort of designed to match the local oscillator better. It's one of those type, you don't often see them, they're usually the same size. But this one's got the smaller one for the high frequency for the local oscillator. Yes, there is a dial cord. You can see it here. So it's down there, poking down there, and some gears as well to make the dials work. So that sounds a bit fun, recalibrating that. There is some information in the radio and television books, but it's only a single page. But I noticed that there's component ident on some of the board. It appear to be on this amplifier. Am I not looking in the right place? Well, you can probably guess it. But yeah, there is some resistor numbers on the RF board, along with some more Hunt's capacitors. Oh, lovely! I love them so much. I think it says that the speaker's 35 ohm. I must admit, I made a copy of my book, and I can't. It's not a very good copy. A pair of transistors on a heatsink. I suppose this 2-part design is a bit like some of the Roberts and Hackers, I guess. There's 4 transistors on the audio board. There's just 3 on the RF board. 2 IF, mixer, converter, RF amp, all in one on the first transistor. There is a tape recorder socket here, which is connected across the volume control. So obviously the volume control doesn't affect the recording you would be making. It's a phono as well, which is interesting. I think this radio dates to around 1963. Perhaps if we look at some of the capacitors we'll find out. It's mounted on a hardboard base, so that's what's inside the red one anyway. I suspect the other 2 are the same, but what state are they in? Quick look at the gold one. This looks like this one has seen a lot of damp. There's rust on the transformer, on the circuit board, and yeah, that doesn't look too good, does it? I had great trouble getting it out, but that's because the gold gauze has fell out. So that one looks a bit of a wreck, doesn't it, as well? This one isn't looking very good either. There's a lot of corrosion around the phono socket. I reckon it's had a battery left in that. At least it's got most of the knobs. Okay, yeah, that's interesting. Yeah, bright's missing from it, isn't it? This one, I've got a feeling this one has. I've undone the screws underneath, but when it's hard to get out the case like this, it tends to suggest that something has stretched or got damp or something. Oh dear. Yeah, battery leakage. You always hope that PP3s don't leak very much because, you know, they're double cased, and that's what I like about, sorry, PP9s should I say, they're double cased. This one did have the 2 screws holding the bottom on, but yeah, this one's got different transistors in the looks of it. That's got a Fawn transistor, really. AC113. Interesting. Oh, this one looks like it's had the transistors changed. They look like they might be, might be IF127s in it. Ah, good. So I might steal them out of that one and put them in one of the other sets. But I don't know. I think there's just the one we first looked at that's really restorable. These just look a bit wrecked. Okay, I've hooked up a power pack to it. Let's see what happens. No current draw.
Not at all. No, Gabriel,
good grief. Oh, that's good, isn't it? So one band is working, which I think is medium wave, but long wave appears to be dead. Or appears to be, anyway. Well, that's not what I expected. Very dead. The wave change switch has come loose, I noticed. Nope, nothing. Sounds completely dead. Ferret rod's loose as well. The wiring on it. I think this has got some strange winding arrangement on it. What I've seen from the circuit diagram. But no, long wave sounds pretty dead. Actually, it must be the contacts because there's no power consumption. There's 20 milliamps there and none in long wave. So it's probably going to be the switch. It's not making good contact. As you switch it between long and medium wave, it switches the power on, as you can see here. Oh, it's thinking about it now. Just get down to that other side of that pot. Ugh. There you go. I think I've got some in it. With a bit of luck, I can get the long wave to wake up. I've just got to get the contacts on both sides. I think there's a wafer on both sides here. So I just need to work this a bit. And maybe the long wave will wake up magically. And you need to work these switches and knobs quite a bit after you've treated them. Even after you've treated them, you can still end up with them crackling. It's just luck of the draw, really. I don't know why, but I tend to find that 1970 stuff seems to corrode more than 1960 stuff. I don't know if it's because they did put silver coating on. Oh, brights just fell off. Oh dear. Still nothing on long wave. The wires look like they've been yanked out for the power, and hopefully it hasn't damaged the wafer switch. If not, I'll perhaps just have to substitute one from one of the others, which don't look particularly workable on. The gears look covered in, well, grease that's a bit like I get out the tape recorders. Perhaps they use the same grease as BSR do. But anyway, I've got 3, so I think I stand a good chance. At least the AF117s are working, and they actually say made in Holland on them, so maybe they're a different type. I don't know. But yeah, quite a few capacitors and things to change. Don't look like they're giving you a generous amount of wire, and there's certainly no plugs, so it'll be a case of photographs and work out from there. Well, there's the amplifier board off, and of course you can pull it round. There's a little bit of wire in here that's to spare. I suppose if you took this earth off the heatsink, it would give you a little bit more. Pot metal moulded heatsinks, that's interesting. There's a thermistor as well for the biasing. Fawn transistor. I've never seen a Fawn transistor before. That one's a Mallard. These resistors look a bit strange in their plastic cases. I don't know why they're like that. I think at the time I got just some photographs. I know I've got others to copy. Oh, by the way, it's got these screws in that are quite often used to sort of, they're like bolts and Phillips at the same time. Very strange. Well, I've done the capacitors, but I'm starting to lift the resistors now because you've got a transformer in the circuit. It makes trying to measure their resistance really difficult, but you know, you've got 5% components here, sorry, 10% components, and they've risen like 25%. And as it's the bias, I'd rather replace those. I'd rather the bias not be 20-30% out because that could lead to problems later. But perhaps I'm being over fussy, but these resistors are not particularly brilliant. The 4.7 ohms fairly accurate still, within about 5%, but I reckon I'm going to find the rest of them, but having to lift them up's a pain. But there ain't many, is there? It's not that complex. Unfortunately, this device here called a thermistor is faulty. It should have a resistance of about 130 ohms. At 25 degrees, it's 21 in here, so it's unfortunately measuring 600 ohms. Now, the idea of this is, as the radio gets hotter or put in a hotter environment, it automatically adjusts the bias of the transistors. Germanium transistors are terrible for a condition known as thermal runaway. And what happens is, as they heat up, they conduct more and therefore pass more power. And then as they get hotter, they pass more and more power. So they can run away quite nastily. I think it's unlikely, but it's a pity this one's faulty. But perhaps one of the other radios will have one in that's working. But I don't think they like damp much. Okay, I checked out another thermistor in another unit, and it's coming up 500 ohms as well. Now, it could just be they all drift the same way. It's entirely possible. Or the radio television manual was wrong again, which is possible. Mind you, it said this was a 2 microfarad, and it's actually supposed to be a 20. So, you know, I'm not going to go on 100% what that says. Quiescent current is sitting at 21 milliamp. Should be 16 if I'm reading that right. But these electrolytics haven't been changed yet, so they could be leaky, so that may change. Grrr. That's really annoying. Yeah, that is supposed to be a 2 microfarad coupling capacitor, and someone stuck the wrong value in from the factory. Quite amusing, really. Oh, and so to the RF board. Well, it's full of these lovely AF117s. These ones say made in Holland, so maybe they work better, I don't know. There's one diode here which is the RF overload limiter on the front end. So where's the detector? It's inside this can, so if there's a problem with that diode, that means the can's got to come apart, but there you go. It's one of those things, isn't it? Doesn't look a lot on there, does there? Well, lots of lovely Hunt capacitors, don't you just love them? Whether they need replacing or not is a moot point, really. This isn't valve, so they may not leak, but you just don't know. I expect some of these resistors are going to be out of value again. Okay, I've got one that's cracked, so that should be interesting because that would have got moisture into it. So let's see what's happened to this one. 81 nanofarads. What was it originally? Let's have a look. A 0.04, so it's doubled in value. Now let's have a look when we stick some voltage across it. Now this can withstand 150, shall we see? Okay, put 100 on it. Yeah, now that one, now that could affect transistor circuits because that's looking about 500k, depending where it is. If it was in a base circuit, that could be a problem. So yes, it was worth changing them in the finish. I wasn't sure to start with, but I also wanted to just check how this performed on a normal meter with just a few volts rather than 150, and you can see it's 15 megs. So to be honest, the leakage of these is unlikely to affect a transistor radio very much, but the huge value changes could do. Okay then, come on, let's test some of these capacitors. This one's 2 microfarad. The ESR is rather high, even for a small capacitor. Capacitance ain't too bad. This one is 350. Let's see what this one does. Guess the value. That's not bad. ESR's good and the capacitance is not far from 350, so that one's not too bad. It's the luck of the draw. What's this one? Another 2 microfarad? 20. That proves that the wrong capacitor was fitted in the audio coupling. Interesting. I don't know, if the SR's 20 ohms, that might not make much difference in the audio circuit, but if it's a decoupler it would make one hell of a difference. Right, let's try one of these ones. That's 100 microfarad, 0.44. Well, that's not too bad, to be honest. Right, let's see how much leakage we've actually got on these capacitors. This is on 5 volts. I've just got a protection resistor in of 500 ohms just to protect my meter. And yeah, it's not that bad. What's that, 10 microamps? Let's try one of these Plezzies. See if that leaks like a sieve. Ooh. What size is that? 20 microfarad. Now, yeah, that's got a bit of a leak, isn't it? Wow, that's got over 1 milliamp of leakage. It is going down, but wow, that is leaky. Okay. Very slowly, as though it's reforming, which is interesting. Okay, let's try another one. What's this one? This is the 350. Okay, let's try that one. Not so leaky. No, that one's not too bad, but that one definitely was. And I suppose if we try a modern day capacitor. About 10 microamps still. Mind you, I don't know when this capacitor was last powered up. Oop, it's dropping below 10 now. Lower than what I can see on this particular meter. So, yeah. So one of those Plezzies is particularly leaky. So here we've got the output stage of the Ferguson. This uses like an auto transformer. You've got a pair of transistors, push-pull. One is driving this winding and one is driving this winding, but this winding's got the speaker across it. So this transistor's driving effectively through the transformer, sorry. This one isn't really, it's driving the speaker direct. Bit odd. As for the biasing, you've got an emitter resistor, so that'll make the transistor switch on a little less hard. You've got 8.2 here on the collectors to the base, so that's biasing the transistors on. And the centre tap, which of the driver transformer, it's got the thermistor and the resistor on it, so whatever the resistance here will control how much base current is going into each of these transistors. So they need to be matched because we've only got one emitter resistor, not two. So yeah, this emitter resistor will help make this not quite so violent when it moves up and down, because when the transistors start to turn on, this emitter resistor will mean that the emitter will rise, so that the transistor will start to turn off again. These capacitors are probably to roll off the audio response, possibly stop it oscillating. Interestingly, there's quite a feedback path here to the driver transistor. In fact, the collector of this output transistor is driving the base of the driver transistor, so there's a lot of audio feedback. I would imagine this causes a little bit of mismatch and causes distortion. This bypassing is weird. Normally you'd expect it across this resistor. It's going actually up to the negative line, which is the rail at the top. This looks a fairly conventional amplifier, and they've not bypassed it, probably to increase salinity. So yeah, I don't understand, looking at this, why they didn't just use a conventional push-pull, really. I think that would have been easier, and you wouldn't have needed a transformer, so I'm a little bit puzzled by this one, but there you go. But they do still use the conventional splitting transformer to get the two opposite phases to drive each transistor. Right, well, I think I've finished with the RF board for now. The AF117s are working, leave them alone. There's a couple of bias resistors and the emitters I've changed because they've gone about 30-40% high, and this is only a 7 transistor set, so we don't want to be losing any gain, do we? So it looks like that's the oscillator coil. These are the two IFs. That will be the demodulator one with the diode inside, so that's the final IF. So there's 3 trimmers. There's a pair here, I think. Somewhere. I think they're around the other side. There's a pair on the tuning capacitor and there's a second one here. I'm assuming, looking at the diagram, it might be for long wave, and it just trims the oscillator. There doesn't appear to be any way to adjust beyond what there is on medium wave for the sensitivity of the coil, so maybe you move it. That's certainly nice dust bunnies there. I think these 2 little screws here, they got a feeling I take them out and don't lose the washers. So very, very small. Oops. Yeah, don't lose the washers. And what have you done? Lost the washer. Oops. Bye bye. Oh well. Anyway. Ah yeah, look. Ooh, yeah, they come out. Did I want to do that? Oh no, they look like they're latched in some way. Ugh. Anyway, I have to try and find that washer now, won't I? But yes, they come off, and these screws will probably remove this top bit once I've removed the knobs. Okay, so after seemingly taking out millions of screws, that's what it seemed like, the top is now off. That's the dual shaft. There is a little bit of cord, and of course these have come unstuck, which is just as well actually, because there we go. We can see there actually is a spring in there, so you would have to pop that up if you had a problem with this cord anyway. And there's loads of really thick treacly grease there and dust bunnies and everything else, so I'm going to get this cleared up, but I think this one's loose as well, so I better remember to put the long wave on the long wave and the, yeah, whatever. Okay, so this is the other side. There's the 2 presets. Well, the local oscillator is going to be the smaller one because it's higher frequency, it's smaller capacitor. Let's have a close look at these gears. Yeah, nice bit of treacle. Right, so here is the selector switch and the pot. There is some polystyrene capacitors hanging off it. There's a resistor. A very long blob there as well. So it looks a bit of a mess, but yeah, that is basically the pot. So what's happened is where it's looped over here for the positive input, the pin has slipped round. I've managed to put it back into position, so it should now work on long wave now and enable power to be given to the set. I've degreased the big cogs, and yeah, a bit messy. So we're making good progress. Looks like I've got some chrome shine, so let's have a go at these, see if I can get them to come up a little bit. Knobs certainly look better than they did. Still puzzling over why on medium wave you've got this extra coil to couple into the converter. That's making me puzzled. But there we go. Anyway, all this grease is now cleaned up, so I can re-lube that when I'm ready. The rubber parts still seem quite soft, so I think I'll leave that. Out of curiosity, I just wanted to check the speaker impedance, and it is 35 ohm. It's always a problem with something like this. If you haven't got a spare speaker and it fails, I suppose I'm lucky in having 2 spares, but I'm just going to trim the IF now. The IF on this one is 475 kHz. First of all, I experimented with disconnecting the ferrite rod and injecting at the point, and what I've discovered is the tuning on the first IF went miles out, so it must have been affected in some way. So I decided to leave the ferrite rod connected and just couple in with a 470 puff. So I'm just going to go through here. I've got a tone, modulation, AM modulation. I'm just going to just trim them in turn and just check on the meter set to AC volts across the speaker, and I'll see how that see if that improves things at all. I doubt there's much room for improvement. I don't think it's far out in any case. At the moment I've decided to couple into the car aerial input, and I don't know if that's a particularly good idea, because I'm worrying about it dampening the ferret rod again. But I'm just going to set the local oscillator. I've got it on 600 kilohertz. I'm tuned to 500 meters. I'm hoping. There we go. Little bit of interference from the bench, but yeah, then I'm going to have a go at adjusting the local oscillator for the medium wave on the capacitor, and then there's that fixed capacitor there for long wave. Now going to adjust the local oscillator, which is the capacitor with the smaller vanes. There's a little preset round here. There we go. It's almost fully done up. Just swing it. Yeah, there we go. Look at that. Spot on 200 meters. Now I've got 1400 meters on the dial, and I've gone for 214 kilohertz, which is close enough. So that sounds like the local oscillator for long wave is now set. So that's basically the local oscillator is all good now on medium wave, long wave. My next problem is trimming the sensitivity of the ferret rod. I think the first problem is this, which is loose. I'm going to try and see if I can figure out where it should be. So there's that, and there's one trimmer on here which I guess is only going to be really useful for medium wave at about 1500 kilohertz, where I trim the local oscillator. Just trim that for maximum sensitivity. There is definitely some improvement, or seems to be some improvement moving this along, but I think I'd rather try it on medium wave and see what the improvement is. There doesn't seem to be quite as much movement on the medium wave as there was the long wave, so I'll set this up and peak it on long wave. I also noticed my local oscillator is slightly out. I only did the trimming once, so I'm probably going to have to go back and repeat it again. I'm now adjusting the larger variable capacitor to just peak the signal at 1.5 megs or 200 meters, whichever's more appropriate. And I'm sorry about the whining noise. Seems to be peaking about there. Oh, there we go. I think the problem with using a ferret rod, a transmitting aerial, is because I'm in the way of it. So as I move around, I affect the reading. But I think that's about as good as it's going to get at the high end. No adjustment at the low end, so there we go, that's done. So I think that's a line now. Okay, I'm just looking at the bias current. It is a little bit higher than it should be. I'm still not sure about this, because if it had a colour code on, it's definitely fallen off, and so has it in the other set, so that's thrown me a bit. And I haven't really found anyone got any VA 1040s for sale. But putting that aside, let's have a bit of fun. But I've got to be a bit careful. Right, here is my heat gun. I'm going to warm up this plate here. Get it warm. Yeah, it's warming up. Then watch the bias current. You see it increasing. Go. I'd say they're up to about 40 degrees now. The current is now 30 milliamp. There we go. Takes some while for the current to go back down to where it was. It's still going down even after 10 minutes. So what we'll do next is we'll put some heat on the thermistor. I know the thermistor isn't working properly, but we'll still do it anyway. So let's give the thermistor a little bit of heat. Can you see the bias coming right down now? Wow, look at that. Wow. Cool, that's come right down. But now I think that explains exactly why the thermistor's there. So if the radio's being used outside in a hot day and the sun's beaming down on it, it doesn't start turning the bias up so high that it zaps current out of your battery. And you know, to be honest, all the manufacturers try to get as much battery life out of these radios as they could, and they actively promoted it. So you know, long battery life, because batteries weren't cheap then. I thought it would just be a bit of fun to show you what happens when I turn the bias off. So bias off, on. You can definitely see the little hump as each transistor switches on. And you can hear a change in the tone. You can hear multiple tones. Because we've got distortion, it's not just 1 kilohertz you're hearing multiple tones. But yeah, you can see the importance of having some bias. You've got to drive it from class B into class AB, just so that the transistors are always on in this little tiny region here, their base emitter voltage. Okay, I've got the set back together. I've done the best I can for the chrome. I think it's a bit pitted. I'm not sure how I can get that any better, but the battery was an awfully tight fit. Someone said that the batteries have got bigger, but there you go. I'm ready to go back in now. It's just a pity about this. I'll have to have a think about that, see if there's something I can do. Okay. Quite lively. It gets everything that I would normally get on medium wave round here. So it's quite sensitive.
Yeah, nice.
Not a lot on long wave though. Just 2 stations.
What a place.
Thanks for watching. That's the Fieldfare Ferguson, or the Ferguson Fieldfare even, whichever way around you want to say it. So another Ferguson for me to play with. I've had these for quite a while and it's been nice to actually get round to getting one working. Sounds alright. The case does rattle a bit when you turn the volume right up, but it does go quite loud considering it's got a 35 ohm speaker. I suppose I've made a few little Fulbies in this, especially with a line in it. Obviously removing the ferrite rod connection to try and align it seemed to push the IF off, so I know now just to use a coupling cap into the base of the converter transistor. Anyway, thanks for watching, and I'll see you very soon.